Let's leave behind all the theories and understand the design of experiments with this simple experiment. Later, we will dive into more in-depth approach while designing our experiments. Suppose you are a commander of war and heading towards a fort. You need to break the walls of the fort with the help of firing from a catapult. The condition is you cannot go near the fort wall because the enemy army is huge. So you must fire from the catapult from a longer distance. The problem is you have just a few cannon bullets, so that you cannot just test fire and see if the fort wall can be broken. Also, you need to be precise with the height of cannon bullet or with the bungee position, pin elevations and the firing angle. These four terms are the factors in designing the experiment in this case. We will learn what are the factors and other related terms in more depth in the coming lectures. So, we need to fix the firing height, bungee position, pin elevation and firing height in order to reach the target so that you can break the fort wall. War is all about preparation and precision. You are a confident commander because you conducted an experimental design before the war itself to understand how exactly must be the position of the height of the cannon bullet, the bungee position, pin elevation and the firing angle. You knew before the war that if you fire from certain height, say height X, maintaining some bungee position, say Y, and pin elevation, say Z, while maintaining the proper firing angle, you will meet your target. In short, you designed the experiment before the war itself so that your odds of winning the war increases. The war and the cannon example here are just the examples. You may be in various commanding positions in your own war of professional journey. If you are a formulation scientist like myself, you may be concerned over maintaining the optimum parameters for getting the highest uniformity of the drop or making drops of highest quality. If you are a civil engineer, you may be concerned over maintaining the optimum parameters for increasing the strength of a building or a bridge. If you are a mechanical or an automobile engineer, you may be concerned over the optimum design criteria that will give the highest performance of the automobile. I can go on and on for every profession for the use of design of experiments practically in our day-to-day professional life, because design of experiments is a huge topic and it can be used almost in any professions. So let us throw all the garbages of theoretical definitions and make our own based on what we learned so far. Remember what we did when you were commander of the war? You designed the catapult factors by adjusting them so that you could meet the target, and this caused you to improve your odds to hit the target. You could make the profits through reduction of the cost and wise utilization of the resources so that there were least chances of the failures. In summary, design of experiments is a systematic process of problem solving by adjusting the factors correctly so that we can reach the particular target and make wiser utilization of our resources so that we can save time, energy and cost of experiments.